Is the audio fine? Everything is okay, I hope. Okay, beautiful. All right. So I guess on with it. We're gonna start here. Just in case, I don't think we have. I don't expect us to have any challenges regarding, for now, anyways, regarding the issue with the limit, right, associated with Google Meet for now. But just in case there are people that may have trouble with, yes, no, it's this thing here. Just in case there are people that may have trouble with Google Meet, what I'm going to do is I'm going to attempt to also stream this thing as well. Okay. So just let your colleagues know if they're going to be people that will be complaining about connectivity or something. Just have them go to the YouTube or something, and I think I've started here streaming, and I don't know why I can't see anything here. Since I've started streaming, and then you can have them kind of like check or something like that. Just quickly check from here if I'm streaming. I have no idea. I think I am streaming actually. This thing says 14th. Thing says I'm streaming, but you never know. You never know. You never know. You never know. All right. So we're going to continue our discussion of CSC 4792, which is data mining. Okay. And let me just see here. So we've got into a stage where okay, so this thing says I'm live, which is good. I'm going to share this thing in the chat. So I'll ask the course representatives, or I mean, if you know of a colleague who is having trouble connecting to Google Meet, just tell them to use YouTube Live. I've noticed there's generally a lag here, there's a delay there, but at least you'll be able to follow through with what is going on. All right, so on with it. I don't know if you guys have any questions so far. We've only had a chance to discuss what we've been calling Administrivia, right? So in essence, we're looking at what do you call this? An overview of how this course essentially is going to administer, ideally. I don't think that I don't expect there to be a lot of questions associated with Administrivia, but the only thing I would like to bring to your attention is that assignment number 1, which is team composition or team selection, is actually due tomorrow, right? You are going to lose marks if you do not self-organize into a team of 5 individuals by 23:59 tomorrow. It's a very simple task. I really don't expect you to have challenges self-organizing into groups of 5, right? I don't expect you to have challenges, and no funny stories like registration. I've already received very weird, what do you call this? Is it emails, right? People making claims or misrepresenting what is going on. No, I'm not registered yet, which is why I haven't formed it. Like the publicly accessible spreadsheet does not require you to be fully registered. I mean, I expect you to be registered by now, but the public accessible spreadsheet really does not require that you're fully registered, right? You literally just have access to it. Just want to make sure you have probably a Gmail-centric account. I prefer your CS account, but if you want to use Gmail, that's up to you. So that's that. I hope you've kind of taken note here. I see a hand up here before maybe we start. Yes.
Yes, sir. I noticed the issue when it comes to signing in or registering our groups is that some people are entering the details on where other people are putting theirs and just like erasing it. For example, for us, we are in group 1, and every time we register, we find that someone else erased our names and then they put theirs again. We keep like emphasizing the same thing even in the group chat, the main one, but people are still making the same mistake. So I was wondering if there was like maybe a way we could maybe mitigate that from happening, because like I don't understand why the mistake keeps happening.
Yeah, well, so what we're going to do, right? If there are people that are doing that, these are people that probably, it's quite sad, right? If you have people who are in 4th year and they're struggling to use computer software, application software, then there's a bit of a problem there, right? What I'm going to do is, if you're making that mistake, you better fix it, right? Because what I'm going to do ultimately here is, what I'm going to do is I'm going to go to the spreadsheet itself. We're versioning the spreadsheet, and I hope people are following through here. We are versioning the spreadsheet. So if there's a complaint, right? If there's a complaint about people erasing, I know I do apologize here. I'm a bit distracted because there are people that are attempting to call, and I need to kind of mention to them that I'm in class or something like that. And, you know. So if there are people that are doing this, right, what I'm going to do here is, like, if you notice, group number 1 or something, right? If there's a bit of a problem, you can flag it after tomorrow, right? So on Saturday, if there's an issue, what I'll do is I'll just check the versions, is it? Because every time a change is made, right, it's versioned, right? So we'll be able to figure out exactly who is deleting people's details, right? And you're going to be penalized here. In fact, if you're erasing people's details, right? So assuming people from group number 1, if you look at the spreadsheet right now, people from group number 1 have already entered their details, and then at some point you decide to do something funny and you erase their details. What I'm going to do on Friday, if I get a complaint, is I'll ask people from group number 1, right? A simple question. When exactly did you, sorry about that. When exactly did you fill out your details, right? And then if they tell me to say we did this on maybe on Monday or something, or on Tuesday itself, but our details were erased, what I'll do is I'll go to the version, the version where they claim they added their details. And if truly we find that you erased their details, we'll assume that you haven't really selected a team. You know, so it's a simple thing here. There's a total of how many groups here? Project team 1 all the way up to project team 50, right? And I know this is more than enough, right, to go around. You know, and the group numbers have nothing to do with this. It doesn't matter whether in project team 1 or project team 50, it's inconsequential, right? What you just want to do is, if you find that people have already claimed team 1, just find an empty spreadsheet, right? If I randomly check here, I'm going to check maybe team 37, I'm sure it's empty or something. Okay, it's there. Probably 50 is empty, I don't know. Team 50 is empty, right? Team 49 is probably empty as well. Just get the worksheet, right? The sheet that has no details, right? And claim it as your own, as a group. You understand this? Does that answer your question, Mr.? Okay. I don't know if there are any other questions. We clarify this. The other thing, right, about group composition is the way this works, right? I've seen it before in other courses where I've taught this. I've had students self-organize. You kind of like have a situation where people, like without permission, right? You find a group that has maybe 2 people, or I don't know if it's like 3 people, and you're supposed to be 5. You just add your details there. This is not how it works. This is not how self-organization comes in, right? The normal thing for you to do, right? The correct thing for you to do is you have a discussion with people, with potential project team members. Sometimes that discussion can be implicit, is it? You send a message, maybe on the mailing list, the mailing list is there, or on your WhatsApp group, if you have a WhatsApp group, and you ask, are there people that are looking for a team member, right? I don't have a group yet. And if there are people that are willing to accommodate you, you ask them, right? What project team, what project team are you, right? Maybe they'll tell you we are project team 38 or something, and we're looking for 1 team member. And I say, oh, like this group here, right? You only have 3 people. So there are 2 people missing. You approach them. And I'm assuming at this point, right, we're halfway through, you're in 4th year. I'm assuming that you know each other. At least you've interacted with some of these people. If not, you've probably interacted with at least one team member who is a part of that group. And so they'll probably be able to vouch for the others, say, well, I think we'll be able to pull this off if we join this group or something like that. So self-organizing just doesn't mean that you randomly start scanning through this document, and then when you find that there are 3 people, you just add your details without getting permission from the others, right? You speak to people, is it? And you get confirmation. Does that make sense? I don't know if there are any other questions. There's a hand up from Boniface. We'll start with Boniface and then we'll go to Christopher. Yes, Mr. Boniface, you have a question? You have a hand up.
Yes, sir. It's actually the same. I just need a clarification from you. I'm the one who even actually sent you an email yesterday complaining that I was unable to enter my details on the spreadsheet. So what was happening?
And I think I responded to you. I told you that I
yes,
don't think, yeah. Okay.
Yeah. So I spoke to group 13, and then they accepted me to be one of the group members. But the problem was when I was trying to enter my details, it was not enabling me to enter the details in any of the slots. When you check the group there, you see that there is a member remaining. So I was unable to enter my details. That's why I was wanted.
Yeah, what the thing is, I think I provided you with details about this. I mentioned that for you to edit this, right, you've got to send an edit request. Is it from right within Google Sheets, right? There's a provision where you can request to edit the document. And the reason I'm doing this is because it has happened in the past. If I open it up, these things will appear as anonymous, right? We won't be able to know who is messing up things, right? But if when I close it off like that and I explicitly have you request for edit access, I literally see who is making changes, what sort of changes have been made. You understand? So send an edit request. If you are still having challenges using Google Sheets, what you can do is go to one of the members from team 13, those that were able to edit, and just tell them, add my computer number there. You can do that. Let them do it for you if you're having challenges. You understand that?
All right, thank you, sir.
I don't know if there's any. Christopher has a question again. Well, I thought Christopher had a question.
The issue is similar to Boniface, sir. So the thing is, we tried to edit his computer number into our group, but it was still failing. So it wasn't able to provide us with that provision to edit.
Yeah, but have you? I don't know. Did any of your team members? Is it team 13?
Yes, team 13.
Yep. What was he unable to edit here? Here, he was failing to add his computer number here on the first one.
Yes. Yes.
Are you sure? I don't think there's a problem here. Maybe he was probably attempting to edit some of these things here. I don't understand here. Just type his computer number and then I'll edit it right here. I don't think there should be a problem here.
It's protected, sir.
Yeah, okay. I will look into it later on. We don't want to start because the way this thing is done is that I don't expect 13 to the protected sheets here don't include doesn't include the things. Anyway, I'll look at it later on and then we can fix this. Okay. Are there any questions? Any other questions? Thanks, Mr. Christopher. We'll try and see if we can fix this later on. We're going to start fixing this right now. Okay. So if there are no further questions, I think we can proceed, I guess. This is good. Yeah, again, I wanted to remind us that, in the event that there are challenges that you're experiencing, any issues or something, as they relate to these data interactions that we are having, please reach out to me via Humphrey and Deborah, okay? And then we'll try and see if we can fix this. I did mention as well when we had class, I think on Monday it was that we're going to try out a few things until we figure out what works best for all of us. But in the meantime, what I'm doing is I'm trying as much as possible to make your learning experience slightly or significantly more positive. You know, so there's a reason why I'm streaming right now, right? There's a reason why I'm not pre-recording, but I'm recording. We are recording all these lecture sessions. They're available. There's a dedicated YouTube playlist. Details of the playlist are available on the Moodle. And I think at some point I'll probably add direct links to these different screencasts. I go a step further by creating chapters, exclusive chapters in the videos, something I think the people enrolled into 4505 should be familiar with, right? So in the event that you probably have technical challenges when we're having a real-time visual interaction like this one, what you can do is you can play back the recording, assuming it's not botched. This is recording, it's streaming at the same time. You can play it back at your own time and be able to follow things through. You know, I'm especially wary of the fact that having a 2-hour-long session here may probably be too much, right? Visual interaction, but we'll see. You guys are fourth years. It may not necessarily be so much of an issue. Okay, so we're going to continue here our discussion of lecture series number 1. We're still looking at Administrivia and course introduction, I think it is. And we had gotten to a stage where we discussed how the course is going to be administered. You know all the prescribed and recommended textbooks. You know the series of tools and services that we're going to be using, right? You have an idea of the breakdown of the continuous assessment score, right? So this course, like most undergraduate courses, uses a 40-60 split, right? Where 40% is allocated towards the continuous assessment score, provided you with breakdowns. Again, as a way of trying to make your learning experience more positive, I mentioned that beginning next week on Mondays, I will be available online between 9 and 10 hours. So if you have an issue similar to the questions people are asking, just join the link. This, by the way, is going to change. This link is going to change to the one we are using now. I've changed the link because I was trying to fidget around and make sure that Google Meet is able to allow me to host more than 100 participants. I know Humphrey and Deborah, I think it's Deborah it was, had hinted at the fact that, you know, we have Zoom or something. I didn't have credentials to Zoom, or at least I had issues with the OTP here. But also, I like the fact that when I'm using Google Meet, there's seamless integration, right? So recording is not so much of an issue. I don't have to worry about a few other things here. But anyways, also I guess I'm addicted to just Google services, right? I'm locked in, kind of. Everything is just interconnected seamlessly, right? So the recording is just being dumped into my drive. I don't have to worry about all those things. The transcription is being automatically done and stuff. And also, all of these services are linked to important things we're using, like the mailing list, which is the Google Groups, right? Mailing list. But anyways, so there's that. We had a discussion about a number of things here. Be aware of academic dishonesty. And then I mentioned assignment. Very, very soon, I believe after we are done with probably, I want to accelerate this, right? Probably towards the end of next week, once we're done with lecture series number 2, or at least once we're done with lecture series number 3, either next week or after next week, we'll make available assignment number 2, where your respective groups will choose teams you wish to be a part of. Topics you want to work on as a team. What I normally do with undergraduate project-centric topics is I come up with topics, hypothetical topics myself, so that we know that people, the relative complexity or the relative effort required is more or less consistent. Okay, I'm going to provide you with predefined, what do you call this? Predefined topics to choose from, ideally. Okay. So I want to transition here to the course overview, course introduction, right? We know how it's going to be administered. And I thought I thought we'd probably try and motivate for why data mining is perhaps important. Although I anticipate there's quite a good number of you that already appreciate data mining, I suppose. And I say this because there are quite a number of projects that I was examining. So CSC 4004 capstone projects that I was examining a few weeks ago, where people are working on problems that are somewhat aligned with data mining. At least there's some notion of data mining, although the focus for most of them is the more interesting things. I mean, where the hype is it AI and machine learning, all those things, right? It turns out that mining of data is instrumental. But also, I've always felt that motivating or providing a bit of context is helpful in having, especially students, right, have an appreciation of why the course is there. At least, you start thinking that a particular course is there just because it's an academic exercise. For you to graduate, you've got to do that course. And incidentally, I remember, I think it was in week 2, maybe week 3 of CSC for 792 last year, when I had this young lady, Miss Nyamba, I think it was, come through, and she was honest enough, came to see me in one of office hours, and she was honest enough to tell me, shockingly, right? What is this course all about? Why are we doing this course, right? And so I guess interactions like those are proof positive that it's always nice to provide a bit of context about the course. Now, if you look around you, right, what you begin to notice here is that this whole notion of mining for data, right, or this whole notion of data mining has more or less become omnipresent, right? It's all over. Yeah, we can actually, cite cases in the corporate world, I guess, where certain organizations, quite some time now already, have decided to actually accelerate, the adoption of AI-inspired or machine learning-inspired solutions, right? Problem solving. So some 2 years ago, 3 years ago or something, ZRA was one of those entities that decided to start experimenting with using, things like drone or something, right? To try and address problems as they relate to tax evasion. So apparently, there are a number of, truck fleets, if you will, or truck drivers that will try and evade tax. So instead of you passing through like some checkpoints, some other checkpoint, you use some back road or something, right? I guess you decide to pocket that money or something. And so what ZRA did, right, is they've set up, what ZRA has done actually is they've set up an AI unit. And I know I've interacted with, I think, is it the assistant director who is in charge of this AI unit in the recent past. We've had a number of people from ZRA attend a series of workshops that we've, kind of organized, right? But anyway, so there's quite a bit here happening in the corporate world, right? You notice here, dating back to some 3 years ago or something. I have no idea how far ZRA has gone here in terms of trying to detect fraud using AI, but what I'm trying to say here is that you cannot come up with a solution that is going to automatically help you detect fraud without mining data, right? So data is actually crucial to all of this. But also, if you look at what we're doing from a societal point of view here, right? If you look at issues afflict society in Zambia, for instance, you begin to notice that there's a potential for using data mining, right? Or at least there's some semblance of data mining taking place. There's an entity called Transparency International Zambia that does quite a bit of interesting things. But in the recent past, one of the things that they did, or one of the things that they've done is they did a detailed analysis of this so-called constituency development fund, right? There's a lot of money that is being directed towards CDF activities, right? In literally all the constituencies across Zambia. This is important really because this money is actually coming from people like you and me, right? This is taxpayers' money. And yes, you, because we all pay some sort of tax, is it? When you're performing these mobile transactions, you pay tax. When you're sending money, if you have a Zap or something, you are paying tax. You may not know this. I don't know how many of you check your transaction history from your bank here, but you notice that there's actually tax that is charged, right? For most of these mobile transactions here. And it's that money that is, part of that money is directed towards CDF, if you will, if that is making sense. Admit all. I don't know why this is. You see, Mr. Humphrey and Miss Deborah, this is why I was saying I can't now have to context switch, right? So quite a bit here. And if you look at what these guys from Transparency International Zambia did, right? When they did this, there was an uproar. People from all sectors of society, of course, mainstream media is usually interested in these sort of things, right? This sells, right? It sells news. This is stuff that people want to read about. Scandals, is it? Is this amount of money from this particular constituency that was never used, right? Or money is being misused here. They claim they used X amount to build a 4x4 classroom block when in actual fact it's supposed to cost maybe a quarter of that or something like that. But it turns out really that this information is actually readily available. So what Transparency International Zambia did actually is they did an analysis on data that is publicly available on the Office of the Auditor General's website. It's right there. So if you find time and you go to ago.gov.zm under reports, you will find detailed CDF reports from past years actually, right? I'm not sure if there's a report from 2025, which is last year, or from 2024, but when I got the screen grab, I think the most recent report was from 2023. Now here's the thing. I have no idea how Transparency International Zambia actually did the analysis of this report, but this is me saying that there's potentially interesting things that can be done, right? If we systematically mine data, okay, and not manually look at these things. I'm just sitting here and I'm thinking it would be nice to actually maybe include this as a potential data set to showcase that we can actually end up doing much, much more than what Transparency International Zambia did, right? If that is making sense, anyways, so there's that. And then, so this is the report I was talking about. It's a long document, really, very detailed, because it's based on all the constituencies across the 10 provinces of Zambia, if this is making sense. Anyway, what else? Well, I guess when I first started teaching this course, right, when I moved back to Zambia, started teaching this course, there weren't really as many people that were excited about data mining or AI and all that, but the rise of the machines, specifically the rise of large language models, most of which have manifested themselves as chatbots like DeepSeek and ChatGPT and perhaps Gemini, for instance, have sort of like opened people up. And the beauty with that is that even government has actually jumped on that bandwagon, right? So the Minister of Technology and Science, for instance, as recently as, maybe not so recent now, but they came up with a national artificial intelligence strategy, okay? The strategy is 3-year long, ideally, right? So they outline things that the government is wanting to do, work towards here, right? It's a very interesting document that I would strongly encourage all of you to read. Incidentally, when we start looking at lecture series number 3, I think this is part of our reading list. Okay, it's a very short document. As with most government documents, right? You don't want to waste people's time with gory details here. You want to focus on the more important aspects here. But anyway, so this thing, the strategy, obviously, if you look at the period here, applies to 2024 all the way up to 2026 or something, right? I'm pretty sure they're going to come up with a revised strategy, which is probably going to incorporate a lot more things. So I'll keep an eye out on this stuff here, right? Anyways, what else? Well, it turns out, right, this issue of data mining, I think is worth mentioning here, especially as it relates to large language models. Okay, and I say this because maybe there are probably some of you that have decided to dip your feet into understanding the science behind these tools that we use, right? Like DeepSeek or something, trying to understand how exactly these sort of systems are implemented or models are implemented. And I'm sure you've realized that data is an integral part of this sort of process, right? So it turns out that behind your typical large chatbot like ChatGPT or Gemini or something is a process that involves mining of data, large-scale data, right? And really, in case you were not really aware here, well, one of the data sets that is typically used to train, right, these large language models, right, because there's a pre-training phase, is it? One of the data sets, well, actually, data is actually mined from the internet, ideally. That's the long and short of it, right? Go out there and you look at publicly available data on the internet. Of course, there are some, I want to say some chatbots, you know, like, I want to look at some specific examples here. That may be trained on data that is not necessarily publicly available, right? And I think the thing that comes to mind here is, I can't really see here. I don't use some of these tools quite often. Just the popular LLM chatbots or something. It turns out that there are some of these tools here that are actually trained on. Yeah, I don't know what this is here, but I'm trying to think of. There's some that are trained on data that is not necessarily publicly available, right? And part of the reason is because there are some entities that actually have access to they have access to data that is somewhat private. You know, like for instance, can somebody remind us because SWORD, is it? There's a chatbot that was tied to X, is it? What chatbot is that? I don't like using that. Yeah.
It's Grok.
Grok, is it? Yeah, thank you. Grok, right? So if you look at Grok, right, and you can tell this, right? You can tell by looking at the behavior of how some of these how they're good at answering certain types of questions. It turns out entities like Grok, largely, in addition to the data set, by the way, that comprises of data on the public web, it's called Common Crawl, right? And it turns out that in addition to Common Crawl, what entities like Grok, XAI, I suppose, did is they actually included data from Twitter or X, formerly Twitter, right? So anyway, but the key thing here is, the underlying thing in all of this is that data is crucial. You know, I always use this as as an opportunity to try and remind people to say, this is one of the reasons why you should pay particular attention to being careful in terms of how you're making information available on the public web. I dare you, right? I don't know if you've seen this. If you try and look up information that is more specific to Zambia, in most instances, right, these large language models will typically hallucinate, right? I want you to maybe just do a test here. Do a test on some of your lecturers, especially from first year, maybe those that are not in computer science, right? And you try and ask, you know, maybe, I don't know if it's ChatGPT or something, to say, can you tell me, can you give me information about, I don't know, Dr. Banda from mathematics or something at the University of Zambia? It will probably hallucinate, right? And the fundamental reason why it will hallucinate is because there's no information publicly available on Rwanda, right? If this makes sense, right? What else? So forget about specific individuals, right? It's like if you try and look for information about specific entities, for instance, right? Let's say large entities like organizations. Again, you notice this search box will hallucinate, right? And I always take advantage of conversations like this to remind people to say, if you look at papers that have been published on what sort of data has been used to train most of these LLMs, you notice that a crucial part involves extracting information from places like Wikipedia, right? Wikipedia, you know, and really, if you look at entities like universities, like University of Zambia, for instance, and you try and check to what extent we've actually carefully curated information, again, you begin to notice that there's zero stuff we've done, right? Yeah, this is like, it's literally a stub, this page, right? And also is a large entity. But anyways, all of this, what I'm trying to say here is that the things that manifest themselves as, these LLMs or chatbots really make extensive use of data mining processes, right? You have got to mine data, you carefully curate it before you can use it to actually train these models idea, okay? Of course, we also have examples that are closer to home. If you look at the device you're using right now, if you're on your mobile phone, for instance, a smartphone, you begin to notice that there's actually extensive data mining that is taking place. You may not know this, right? Or rather, there are opportunities for you to mine data. So there are issues here like Smart Compose. If you go to email, every time you type a certain word, you notice that Gmail will probably know exactly what the next word is going to be. Like in my case, I always start off my emails with, irrespective of where it's going here. If it's multiple people, it's hello everyone, right? Rarely is it dear. So, data has been mined about my behavior, right? And so this intelligent application, I guess, an intelligent service that is integrated within Gmail or within Google Docs called Smart Compose is able to infer, right, what the next word is going to be or something. But besides that, right, you notice that this is like opportunities. You notice that, I don't know about you here, but what you begin to notice is that things are rapidly changing in terms of data, right? I hate this as an example here, but I don't know about you, but I'm part of very weird groups, right, where you have hundreds of people, sometimes thousands of people, right? I'm using this as an example. This is last year's group, data mining, the student group. I was added to it or something. And I rarely would actually go to the group, right, and check what is going on. Why? For me, because I guess I experienced a lot of information overload. I don't know about you, but I find that I find it difficult to actually follow through with information on WhatsApp. And I know WhatsApp has become a very crucial piece of service as it relates to communication, but it's so difficult, especially when I'm dealing with, especially when I'm a part of groups that have a lot of participants. I mean, this group only had like 161 members or something, but there are really weird groups like this ones, Dons, whatever group here, where you have all members of staff, academic members of staff at UNZA. This is like 900 plus, well, not all of them are there, but you have, I think it's close to 600 people. You find people are posting memes, people are posting queries that shouldn't really be posted on that thing, but also at the same time, there's interesting information that is shared there, right? And my thing is always like, I've figured out, like if you look at groups like this lecturers group, for instance, I've figured out characteristics that I guess would be able to inform me whether the message is useful or not. In a given day, you have like hundreds of messages, right? What you can do is you can mine that data in a smart way and kind of like try and figure out exactly how you can be able to derive information. Like in this particular example, you can actually figure out, using data mining, you can figure out ways in which you can automatically extract important messages that are being shared. And this is part of what we're going to be doing, by the way, in this course. But I was just mentioning here that there are a ton of examples closer to home here. Those of you that have bothered to study how Android functions, will further appreciate the fact that if you look at Android, right, there are logs that are generated every time an activity happens. These are like literally detailed logs, right? If you look at Android under the hood, you gain an appreciation of this. A while back, I started a project, and I had a student who looked at a non-technical aspect of this, right? We're interested in trying to harvest logs. I'm still interested in doing this. I don't know how many of you have heard of the Mwau tablet or something. So an entity called iSchool or something. I think iSchool is defunct now, it's dead, but they've rebranded to Mwau or something. They sell tablets, right? Tablets are supposed to be used in educational settings. So they are meant for students that are in grade school. So grade 1 or grade 7, ideally. Okay. So they have like three types of tablets. So there's a teacher edition, there's a student edition, and then there's a home edition, I think it is. Okay. And so anyways, what I've been interested in doing is try and see if we can try and figure out ways in which we can empirically determine the extent towards which these tools are effective, right? And one of the easiest ways is you can actually harvest data, mine data. What years? Can we ask that you please mute your microphone, right? Mr. Christopher. So, do you want to mute your microphone, please? You know, otherwise I'm gonna have to context switch here. Do you think you can manage to do that, colleagues? You just mute your microphones as we're having class. Thanks. Unless if you have a question, you can raise your hand up, and then we can have a civil conversation or something. Anyway, so you can kind of like extract data like that, right? In the inaugural lecture we had on Monday, I talked about some of the ongoing projects in the Data Lab research group, and I mentioned this road safety project, right? As part of the road safety project, one of the things that we've done, one of the major things that we have done actually, and there's actually tangible deliverables that have come out of this, right? A tool that is going to be deployed very, very soon, right? What we've done is we've mined data, right? We've mined data from dashcam footage, okay? So one of my I want to say one of my what do you call this? One of my hobbies, I guess, if you can say that here. One of my hobbies is well, I don't think it's for a while here. I can't note it, whatever. One of the things that I normally do here is I always let's say this here. When I'm cycling, I cycle a lot here. When I'm cycling or when I'm driving, especially when I'm driving, I have a dash cam, right? I have a dash cam, and what it does is it automatically captures kind of like footage, is it, of different parts of Lusaka, right? And it turns out that what we did was we used footage that I've been collecting for years now. I think since 2018, 2017 is when I started collecting this data. So I have a vlog channel, which I use to archive information. And people think and I'm sure people wonder here, right? Because I don't really attract a lot of likes from this channel here, except for people that are in the diaspora or something. But I do this because, you know, I'm archiving specific type of data. This is video footage ideally. So what we did was we used this as input. Yeah, we use this as input. And I guess I can use this as an I have a series of examples where I have not small chunks of videos here, like less than 10 minutes or something, but this is footage from what do you call this? Footage from Lusaka all the way to Siavongo or something. And so what we did, right, in this particular project is we actually used data from dashcam footage like this, right? This is somewhere near, I think it's Kafue roundabout or something. Yeah. If you guys visit town, you don't have to these days because most of the things are closer. Yeah, you don't really have to go into town or something. But what we did, really, the long and short of it here is that what we did is, I think I have footage I'm listening to Pothole or something. What we did, right, was we used this data, we mined this data, right? And I think what I'm going to do is I'm probably going to use this as what I'm going to do is I'm probably going to use this as an example of as a case example, in addition to this text-based footage that we have or something. So what we did was we used footage from the dashcam, right, to train. So we mined that data, and our interest was to kind of like train. I don't know why this is quality here is very poor here. I guess to build some sort of model that that, you know, given input, right? Given input, it's able to tell you to say, you know, kind of like this. And by the way, there's nothing fancy about this, right? You notice actually once we get to the end around August that there's nothing complex about what we did. The interesting thing is that the final output there's an application that the councils and RIDA can actually use, right? Training a vision model like this is not that complex. But what I want to mention here is the process maybe we went through to mine data, is it? Or maybe let me start with maybe trying to kind of motivate or something. Lusaka City Council, I'll give you an example. Lusaka City Council, right, is responsible for this road. I stay somewhere around here. It's close to campus. A place called Jesmondin, Chadley, somewhere there. This road is a responsibility of Lusaka City Council. Okay? So whenever you see a road, most of these roads within Lusaka CBD here, and there are potholes, just remember that the entity responsible is Lusaka City Council. One of the things they have got to do is they have got to monitor, right, and maintain these roads. Now, these are like a lot of roads, yeah? Maintenance currently is manual, okay? So they've got to plan for, you know, we're going to go to this particular area and maintain this. And I know what you're thinking. Well, but Lighton, we have wards, right? Like if you look at Zambia, Zambia is clustered into provinces, constituencies, and then you have wards of ward development committees and all those things. Yes, I know that. But the key thing here is like the municipal council, the city council, right? Or the town council is responsible for monitoring these roads. Now, the problem that is there is that the monitoring process is actually costly, okay? The current way of doing things is manual. They literally have to plan for this. You gas up, right? And we did studies. That's what you gas up, and then you start driving around to try and check which roads have problems. Or you rely on citizens that are, I guess, proactive, right? So Lighton will probably give Lusaka City Council a call, say, I live close to this place, and the problem that is there is there's a lot of potholes. In fact, I avoid Central Street because there's a lot of potholes, right? So it's like, this is not an efficient way of doing things. So what did we do? We said, well, what we're going to do is to try and get around the fact that it's expensive, and it's expensive from a monetary point of view. It's too costly, but also at the same time, it's time consuming, right? I mean, you literally have got to imagine if you're monitoring the Great East Road or Great North Road. You gas up and you start driving around or something. I don't know about that, right? You're spending money, yeah? So what did we do? We said, we're going to build a solution. And the way we're going to build this solution is we're going to build a vision model that is going to tell us, given an image, we want that model, right, to tell us to say, there's a pothole here. Now, that in itself is not very, very useful, is it? Because if you're an entity like Lusaka City Council, you'd be like, well, there's a pothole there, but where is there or where is it here, right? And so what we did was went a step further. So using, like I said, using my data from my large data set that I have here, right? Is it that we're mining? Or showing you another thing here, right? If you remember, I think it's this stretch of road all the way up to Siavongo or something. So using this as a way to train this model, right? We harvested data from dashcam footage, right? So from here. Now, you begin to notice here that, and I don't know why this is not going to probably be very useful here. I'll go back to where I was, I guess. It'd be useful that way. I suppose it will be much more useful that way. So I'm context switching here. So what we said was we're going to use data, right, from dashcam footage. And if you look at the dashcam itself, right, it's like it's a low cost, right? I bought this at what, probably like less than, I can't remember the price here. This is a Viofo, by the way. version 3 if you're interested. But the number of beta dashcams, I got this some 3-4 years ago or something, and it served me quite well. But the thing is, what you notice somewhere at the bottom here, context switch. Please, can you switch off your microphone? Your baby is crying, or your brother or sister or something. What you notice right at the bottom left corner here, right, is there's interesting information, right? So there's the speed. So what the dashcam does is, in real time, it kind of like captures. You can configure it to capture the speed at which you're driving, and every step of the way, the GPS coordinates, right? So latitude and longitude, ideally, if you notice here. And so what we did was we trained this model first, right? So we want this model to tell us, given an image, tell us where the pothole is. But for us, that's not very useful, right? We want to know where that image was. And how do we know what that image was? We now know the image that has potholes, like this one. And then what we do is we go to that image and we extract the text that is at the bottom left corner. We mine the data. So we are mining the speed, we're also mining the GPS coordinates. And then we use the GPS coordinates to provide a mapping tool, right? That mapping tool ideally is going to tell Lusaka City Council, Chipata City Council, or perhaps Chadiza Town Council or something, or Chadiza Municipal Council, I don't know if it's Municipal Council or Town Council, to say there's a pothole here on the map. And in fact, it's a visualization tool, right? Where you have like map markers where you can just click, yeah? And it's just that I've switched computers that have demonstrated the application itself, the way it works. And so the size of the map marker here is relative to how bad the potholes are, how many potholes are there, right? But anyway, so you notice here, there's a problem I've explained, and then there's a solution that we come up with. But the point you want to take away as it relates to CSC 4792 is that for you to build that sort of solution, you need to mine data. And in this case, we are mining video footage. But you remember that in your computer systems in second year, that video footage is actually images, right? It's a series of images, is it? You typically have a video that has an associated rate, is it? You have like frames per second. So in essence, how many images you can chunk into a given second to provide this illusion that it's motion picture. In actual fact, it's not motion picture, right? And incidentally, if you read up on what it is we did, you notice that there are other interesting things that we did as part of the mining process, right? Because if you're saying that you have, let's say you're using, I think my dashcam captures footage at 60 frames per second. If you have 60 frames in any given second, right? Observed. If you have 60 frames in any given second, literally, if you look at the bottom left here, this video footage is what? 2 hours, 55 seconds, right? In each second, right? In each second, there's 60 images. So in essence, right, you can have like potentially 60 images that will capture the similar frames that are associated with these potholes. So one of the problems that we had to look at is, how do we identify the frames of interest, right? It's a whole topic that people have written papers on how you do this, ideally. But anyways, the long and short of it here is a classic example of how data is mined like that. But there's other things that we have done, right? I don't know if I mentioned this in the lecture that we had on Monday, but for the longest of time, we've been working towards a problem that is associated with scholarly research output, right? So this notion that if you look at visibility of research in Zambia, it's quite low, right? Online visibility, right? If you go online and you try and look at research that is done by people from Zambia or something, and I'm not just talking about UNZA, but we use UNZA as a case example. Here could be UNILAS and all those things. You notice that, of course, things are changing somehow, right? This is a rapidly evolving space here. But you find that there are a number of very reputable researchers, right? Especially the old-timers, people that are relatively older than myself, people that either don't care about their online visibility because you're already a professor or something like that, or maybe you've gotten into a stage where you're just too old to worry or bother about some of these things, right? So most of the important research that you've done in the past is in print form, right? It's not online. right? So people will not know about the research that you've done. But there's more really. There's a lot of interesting things, and I'll use you as an example. You know, we have like close to like 300 people, well, maybe somewhere around 200 people that are graduating in May, right? With the Bachelor of Computer Science, maybe software engineering, network engineering and stuff, and computer systems engineering, right? Those people at the end of the year will undertake some research-centric project, and you produce a capstone project. Surprise, surprise, right? In all likelihood, I'll be surprised here because I just moved to the department recently. I'll be surprised if there's a significant proportion of those capstone project reports that are available online. They're not online, right? So anyways, we are working towards this project that is aimed at improving the visibility of research output online as it relates to Zambia. But we're using UNS as a case example. Now, it turns out that there's a series of problems associated with this. And what we've done is we've carved out problems that we feel can be addressed through data mining, specifically by using solutions that emphasize the use of applied artificial intelligence or applied data mining. So we harvest scholarly research output. Now, one of the things we've done as it relates to the current slide is we are solving a very simple problem. Well, simple, yes, but I don't know if it's simple here, but okay, we are building NETD.ac.zm. We are building a national repository, right? We're building what's called a Zambia National Electronic Thesis and Dissertation Portal or something. It's still work in progress, but it's been pending for a very long time here, right? It's still work in progress, but yeah, we're supposed to set up a portal that is going to pull research as it relates to people that are doing masters and PhDs from all the universities in Zambia, make them centrally available. Okay. Now, if you wonder about where's this information coming from, well, it turns out that we are mining this information. We're going to be mining this information, mining in the kind of, not in the literal sense here, but we are mining this information from so-called institutional repositories associated with different institutions in Zambia. Now, your typical higher education institution in Zambia, if they offer PhDs and masters, we'll have what's called an institutional repository, right? The UNZA repository has been dead now for, it's been down here for a few days. I don't know. I always send, guys, I always send reminders, it's back up. So most of these, a number of these institutions have institutional repositories. Okay. Now, the idea behind the institutional repository is simple, right? It's used as a central location where research output for that institution is made publicly available. So you're supposed, if you're looking at research output here, it's things like, I don't know why this is not working here, but things like thesis and dissertations, even student reports, they used to be made available here once upon a time in Zambia. I do this here. Preprint versions of journal articles and conference proceeding papers, right? All of them made available here. Incidentally, one of the data sets we are using in this course is coming from here. This is the reason why I'm going to spend a little bit of time here, right? Once upon a time, by the way, if you look at here, they stopped now, but they used to make available all fourth-year students, right? There would be reports, okay? Student reports. So if you go to this, it's called a community, the student project research reports, you find old capstone project reports from the computer science department, then now it's computing and informatics, available there, right? But more importantly, like as it relates to the problem I'm trying to explain, is there are details of all PhDs and master students that have graduated. So people are doing these advanced degrees, right? At the UNZA. A prerequisite is you must write a long document, a thesis if you're doing a PhD or a master's by research, or a dissertation if you're doing a taught and dissertation master's. Okay, it's a long document, hundreds of pages long and stuff. But what we're trying to do is we're saying if this information is coming from UNZA, I have to fix this later on, right? People are, can you mute your microphone, please? I don't know who that is. Coming from UNZA, from Zikas University. So what we're doing is we're mining theses and dissertations. Okay? Yeah. Theses and dissertations. And I'm looking for scope of natural sciences here. This is probably going to be on the next page here. You'll find interesting work that has been done, by the way. And probably some of you have actually cited work from here in your literature review, in your capstone projects, right? You should truly did a comprehensive literature review, which you should be doing. Now, the problem that is there is that if we are harvesting information from UNZA, from Zikas and stuff, it turns out that it has to be curated in a consistent manner. Fields have got to be common and they've got to be complete, if this is making sense. Okay? One of the things that we've noticed is that, especially information that is coming from the University of Zambia repository, this and dissertation stuff, it turns out that there's a lot of information that is missing from there. When you're doing an advanced, I want to call this an advanced degree at the UNZA, like a master's or a PhD, you are assigned somebody you work under, okay? A supervisor, right? This is the person who guides you throughout the process, if that makes sense. So they'll, yeah, I don't know why this thing is, I wanted to showcase examples of this information failing here. I don't know what is happening here. But you're assigned a supervisor, right? And that's important information. So maybe you'll be working with Professor Phiri or something like that. Now, the problem that is there is that the way information is created in most repositories, and specifically at the University of Zambia, is that if you look at a sample ETD at the University of Zambia, and I don't know why these are failing to open here, all of them. I wanted to use that as an example. They will not have important details like these. Right? So I'm showcasing an example here of my doctoral thesis from the University of Cape Town, right? So my alma mater also has a repository. Now, what you notice is that important information that is supposed to be included is details of who you worked under, right? The supervisor, for instance, supervisors. In my case, I worked with Professor Suleiman and Professor Dr. Christoph Main or something, right? These two people up there. If you look at the University of Zambia repository, what I'm showcasing here, this is from the University of Cape Town repository, and then this and dissertation here is from the University of Zambia. Incidentally, the tools that are used to make available institutional repository are open source tools. Most organizations use DSpace, but there are some that will use ePrints, you know, or Maker, God forbid, or something in orange of tools out there, but that's neither here nor there. Now, you notice here, right, from UNZA, the thing that is missing is the supervisor. We don't know who the supervisor is, all right? So what we are doing is we're saying we need the details of the supervisor so that when you build this national ETT portal, which is going to pull information, mine information from UNILAS, Zikas, Mbana University, Kapasa Makasa University, Mungushi University, University of Zambia, Copperbelt University, right? All centrally located. This has been done. It's just a matter of launching, right? It's stuff that have been working on and I'm passionate about since 2009. But also when I was a graduate student, I worked in this space, right, for my master's. And I also worked as a research assistant helping build the ETD port or something. But anyway, so for us to solve this problem, right, it's like, how do we do this? Well, we're going to mine information. So here's stop here. The problem is the information that is coming from all of these universities, ETDs, right, this metadata, mostly doesn't have supervisor details. Now, we want the supervisor details. What you can do, right, is you can say, well, you can go into these systems and manually update details of supervisors. But wait a minute, let's look at the UNZA alone. What you need to do is you need to pay people, right, to individually go into all the past dissertations, because until now, right, they don't include details of supervisors. So you're going to go to all of the things that have been updated or ingested into the repository and manually update all of the thesis and dissertations. Now, this is taking a while here, but this is a lot of information. Last time I checked, it was 5,000 plus. The problem with that is the process is error prone because they're using human beings. And also, the other problem is it's costly. You are going to have to hire people to update content because it's not a simple process. I don't know why this is taking a while to load here, but I wanted to showcase this. It's neither here nor there. What you can do is you can say, we are going to, instead of doing this, what we will do is we will manually, we automatically, this is the total number of dissertations, 5,725. We can mine information and build smart tools using the data we would have mined that will automatically extract the information we're looking for. And I'm going to give you a reading list here because we've built classifiers, so binary classifiers, multi-class classification models or classifiers, multi-label classifiers as well that can help solve these problems. However, something else that we have done is we built a while back, I think it was 2024, 2023, I don't know. We built an NLP model. And before you start saying, well, maybe something you did here can easily be done with LLMs, yes, you can. But when we're doing this, it was the pre-LLM era, right? Of course, we've updated the paper that we're hoping we can submit here to incorporate an LLM aspect of what we did. But we built an NLP, or a natural language processing model. And the goal of that NLP model is we mine data, and what it does is it's able to automatically generate information about supervisor details. Who supervises this person? Now, there's a whole paper that has been a whole report. I'm going to give it to you as a reading list. I'll try and see if I can also provide you with a preprint that we have currently. It was rejected at JCDL. They told us to submit as a post, so we said no, I guess, because we had a lot of, we put in quite a bit of work. We wanted to be published as a full paper or something. We're still refining it, but I can share the draft version submitted and rejected at JCDL, downgraded to a post or something. And so what our solution does is, the question you should be asking yourself, where are you mining this information from? Well, we went through a systematic process to try and figure out to say, if we have an ETD like this, which doesn't have details of the supervisor, where can we find the details of the supervisor? Well, we discovered that we can find the details of the supervisor. We conducted a study, right? Systematically. We discovered that for UNZA, we find details of supervisors on the acknowledgements page, right? Always on the acknowledgements page. So literally, if you are thinking about, well, what's the data mining thing associated with this? We go online for each of these, think about these 500 items. We download the document, download it, and then we came up with, the students I was working with. The problem with students sometimes is they're too lazy to read like that, especially these days, right? Your kind is it's a very sad generation. You don't want to put in the work here. But I'm telling them, because when you're working on a capstone project, I'm not going to tell you what to do because it's an exam, right? You have to learn and demonstrate that you're able to do this yourself. I'll be able to guide you, in some cases, provide solutions. So they came up with, I told them, if you are failing to come up with a smart way of extracting content from the acknowledgement section, because when we had discussions, right, they discovered that in the guidelines, postgraduate guidelines, acknowledgement section is always page number 7. So their thinking is, we're going to download the page. Guys, now what you do, you guys, we're going to download the page, and when we download that page, we download that page, and then we're just going to extract. This is the thing. This is what they were doing literally, right? Sad initial iteration, right? Well, what we're going to do later on is we're going to it's page number 7. This one now, right? Just going to convert this to PDF or something. It's page number 7, right? So what I'm going to do here is I'm going to you have wrappers, right? I can use a wrapper like PDFTK, but you have PDF Plumber and all those things, right? We're going to use this as, we're going to use this, we're going to get this, we're mining this data by getting this, and then what I'm going to do is I'm just going to get page number 7, right? Or something like that, is it? I'm going to get, I'll call this arc or something. I want to get page number 7 and hope that, not hope really, but, and if I open this page number 7, if I open this up, it will probably have the acknowledgement section. But surprise, surprise, right? In this particular case, page number 7 is not actually the acknowledgement section. And I know this is like, it's actually not page number 7 in this particular case. It's probably page number, this is a classic example, 1, 2, 3, 4, 5, 6. It's page number 6 in this particular case. So they ended up, the initial iteration of their solution had a problem, is it? Because if you say we're going to get all the 5,000 documents and just get page number 7, we are mining information from page number 7. You discover that what you have on page number 7, like in this example, is actually not the true acknowledgement, is it? But the acknowledgement in this particular case is on page number 6, right? You don't manually do this using like the tool I'm using right now, is it? You would have to you can do this programmatically or something, right? So you extract this, and then you convert this into text, and then you do analysis here, right? Incidentally, the final iteration, again, they failed, right? I helped them out with a brute force kind of solution where I taught them, well, what you can do is, because you know that the acknowledgement section is not going to be at the end, it will be at the beginning, it will be part of the preliminary pages. It will probably be the first 10 pages. Do a brute force technique, right? A heuristic where you're just going to be scanning, check if page 1 is acknowledgement. If not, go to page 2. If not, it's a loop now. You understand? Maybe a while loop or something. Or it can be a for loop, right? You loop 10 times or something. Go to loop number 1, check if page 1 has acknowledgement. No. Page 2, no. Page 3, no. Page 4, no. Page 5, no. Right? Page 6, oh, it has acknowledgement, break, right? And extract the date or something. Right? So, and there's a notebook, I'm going to share this with you as well, that that outlines, I don't know if the report from the students actually has the heuristic or the algorithm that they used at the end of it all. And then afterwards, right, we mine the data. The interesting thing is, usually when you're mining data, right, you just don't mine it for the sake of it. Well, sometimes you're mining it to analyze, just to kind of like deduce patterns or something. But most times, or many times, you're mining the data because you are interested in extracting information. You're interested in building inference models or something. In our case, we are mining the data in part to build a natural language generation model, right? So NLG is a subset of NLP, ideally, right? We're automatically generating content. And the content we're interested in generating here is, we want to extract supervisor details. So when we get the acknowledgement, we convert it into text, and there's a whole bunch of things we do. But ultimately, what we are interested in is, observe this, right? Stuff like this. In some instances, you have multiple supervisors, so you'll be able to extract interesting things. So what these guys did, the 4th years only managed to build a rule-based model, right? After they mined the data, they built a rule-based model, which ideally was using rules, is it? So they use Spacey as Space is an NLP library, just like GenSim or NLTK here. And incidentally, for those of you that are interested in this, perhaps you may be doing something that is kind of like related, I suppose, to this, like you are building NLP models, you may be interested in looking at the Capstone project report itself. So it's here somewhere, I think. The Pothole report is here, by the way, but I'm looking for Nyambe here, Fraser Nyambe. There we go. So a while back here, in 4 years, right? This is why, in case you're wondering, I want to share this with you in case you're interested in reading this further. We may not really use this as a case example. We are only supposed to look at classifiers, and I think we're supposed to look at supervised machine learning and unsupervised, right? So we're going to look at classification models and clustering models. That's it. That's only as far as we're going here. But in case you're interested in this stuff, you'd be doing this. So anyways, that's this, right? So we are mining. Now you notice here, right? In all these examples I'm giving you, we are mining data, right? But we're mining different types of data, okay? But it turns out that what we're doing in this course is we're trying to get a better understanding of the generic process we go through to mine data, whether it's images, video, sound, or audio, right? Whether it's text, we don't matter, right? The process can be generalized ideally, okay? So anyways, in this particular case, we are mining PDFs, and then we are harvesting information from specific sections in the PDF, ideally. And then again, as part of this broader project, by the way, details of the projects are aligned with what I'm talking about right now, are available on our research group website. So if you go under projects, go to the Zambia National UTD portal. There, I don't know if it's up to date. I'll have to update this. There are students that have worked on projects or related projects and capstone reports and publications that have come out of this project, right? Including details of the classifiers that I was talking about here. I'm going to use them as an example. And I think one of the reading lists is a seminal paper that I submitted the International Journal of Metadata and Semantics or something like that. So it's related to this as well, right? This is linked to us building classification models. You notice here, when we're building classification models, there are a series of projects that we worked on. A project that was aimed at building binary classifiers, project aimed at building multi-label classifiers as well, right? So sub-project. There's even a master's dissertation by it's a very dear colleague. He's become a colleague now, Robert Msendo. He's, I think, ICT director at NIP or something like that. Very smart individual. But anyway, so there's that. I'm going to save this because there's a reading list. I want you to go and read the paper that is somewhere towards the end. I don't want to waste time to talk about this because also besides the paper, I used 2 examples in this course. The data set I'm going to use is going to lead us to a stage, hopefully, where we are demonstrating how to build a classifier using this data set, right? But what you need to know here is that we built binary classifiers, and maybe I can share just the publication itself. There's a journal article. There's a journal article which this is it here, right? So if you want, you can go here, right? I'm going to share the link here. This paper, this publication has it has details of how we mined the data, which should be stuff that would be of interest to you. I'm going to share this link direct to you right there as well. But it also has details of, I'm just going to download it instead of using my PDF viewer in the browser here. It's a lot easier for me to annotate things like that or something like that. I don't know. So it has details of the way we built. I don't want to scroll down here maybe to showcase interesting things here, like I don't know what would be interesting here, but let me see here. Of course, I mean, what do you call this? An outline of what the problem was, you know, what problem we're trying to solve. And then, yeah, outlining exactly why we were building these classifiers, right? I'm going to scroll down here. We're outlining where we're getting information from these classifiers. So this particular, I think, binary classifier, we're getting information from the title page, but also information from metadata from the PDF document. So you know how, besides PDF TK, you can do PDF info. I don't know if you use PDF. There are wrappers for all these tools, is it? I do PDF info and do a sample PDF here. You have this information here. So the way we're mining this information is getting metadata from PDF document. You know how a PDF document, right, like this, if you go to file properties, is it? You have access to this information. It's doubling co-encoded information here. This is the metadata we're looking for. But you can kind of programmatically pull this information, right? Right? So we're extracting things like this. Where is that? It's file size or something, and also the length or something like that, right? So anyways, the paper outlines where we're mining this information, different places, including metadata from OIPMH and stuff like that. And then overall, towards the end here, what you have is you have an outline of the different types of classifiers, right? So we had a binary classifier which was able to classify, or which classifies actually the type of the ETD, multi-class classifier, which classifies the collection, right? And then I think in here was preliminary work associated with maybe not in here, it's a different paper. Incidentally, these things are also available on my GitHub repository if you're looking at the implementation. So if you're looking at implementation of these models, I think on my GitHub report, I know they're there. They may be a bit outdated. I've not really updated them in a very long time because this is stuff that was done a long time ago. It's been a couple of years since we started working on these problems, these and related problems. And by the way, this kind of shows you maybe some of the things that researchers do at UNZA, right? These people that teach you at the UNZA. They will, you see here, do I even know ETB? Do I even know the type of, maybe this has, when you're working on long-term GitHub, when you're working at long-term projects here, GitHub, this is the thing here. I even had deployed endpoints, API endpoints on Heroku. I don't know if these work here. I'd have to revive them because otherwise they'll end up not working, is it? I don't know if I deployed them under the Data Lab research group kind of repository also. But in case you're interested in this, there's repositories. There's source code that is available. There are models as well. They are frozen, right? These are Pico files. They're frozen in time, kind of. And you can probably look at them at your own time if you want, right, as a starting point. Yeah, they're not here. So they should be somewhere in my. They should be probably somewhere in my my personal probably my personal GitHub repository. I can share these at a later stage, I guess. I don't know. Maybe not. I will share this because it's important so that you can actually play around with them. So right on, I think on Heroku as well. I don't know if it's actually still works here. I can check. If you decide to download them, you can do this also. But I don't know if this is still available. Heroku, I guess, have been inactive for a very long time. Crap, it's not there. Okay, that's okay. I will try and see if I can classification. I'll try and see if I can find I can find the models so that you have access to them. Anyways, so there's this and related problems, right? Now, again, something else I'm going to use extensively as a case example. Incidentally, by the way, but Lighton, what's going on here? The data set, I'm going to share these things up front because of how we are learning here. I want you to probably kind of already get up to speed with some of these things here. So I'll share the data sets that I know for where we're going to be using. And just give you an idea here, right? I guess I don't know about that playground or something. I'll give you access to this data set, right? So this data set, it's a fairly kind of I want to say I'm using it because it's homegrown and then something that you can easily relate to, but also it turns out that it's a very simple data set to understand. So if you look at the attributes, right? If you look at the attributes here, you'll notice that the attributes are not as complex. I've forgotten the what do you call this? The number of columns. So it's notice, right? How many attributes? 1, 2, 3, 4, 5, 6, 7, 8 attributes, right? Just 8 of them. Quite simple data set to follow through, right? So things like this. That's it. part of the reason we're doing this is it's a lot easier for us to demonstrate how you build classifiers, right? Because I'm going to show us how to recreate the classifiers we built in this paper here. I'll showcase this one, right? Is classifiers. I have a demonstration in the paper that shows you the outputs of the models, is it? So one of them is a model that outputs yes on whether it's a yes, masters or not masters, 0 or 1 or something, right? In this particular example, it shows you that, oh, this is a master's dissertation or something. And then in this particular one, it outputs the class. So the class would be these things here. If you were paying attention, when I was showcasing, I know how much of this you're paying attention to here, but I was showcasing, maybe I wasn't, but theses and dissertations are associated with a series of collections, is it? This is coming from natural sciences. There's some from medicine and stuff. So what we built is something that tells you to say this thing belongs to Graduate School of Business, or it belongs to School of Natural and Applied Sciences. Then it was School of Natural Sciences, or this thing belongs to School of Education, right? So we are predicting this, and even have like kind of like scores, right, for each of the different schools ideally. This is a classic, a nice example because it will help us discuss dimensionality reduction and all those things here. I guess and stuff, right? There's a multi-class classifier, right, which is why we have the confusion matrix here. Anyways, besides this, right, the other project that, and I think I mentioned this at the very beginning, I also use this as an example because you can easily relate to. For the longest of time, for 5 straight years or something, I used to teach a computer systems and architecture course. Now the failure rate, computer systems or computer architecture is hard, right? Especially computer architecture. The failure rate in the course is quite high. So this is a problem, right? Failure rate is high. Well, so what if it's high? Okay, as course instructor, I don't really check the fact that students fail. And I do guess I want everybody to pass, right? But there'll be people that will just not be serious. There'll be people that will genuinely find it hard to engage with the course or to understand what is going on. Okay, so I don't like students failing, right? I don't want students to fail. Okay, what else? More importantly, the government invests money, right, in education. Most of you enrolled into this course have gotten loans, right? You're using taxpayers' money, reclaiming, loans and stuff. I mean, that's a whole different topic here. I don't know to what extent the loans board has been successful at getting back the money, right? I say, certain people, my immediate brother here has been paying back, right? And well, it's easy if you're in the government, he's a medical doctor, so they deduct whether he likes it or not or something like that. So the argument here is that besides the fact that Lighton doesn't want students to fail, well, it's like government is investing millions of kwacha into this, right? Through loans. And for government to claim, people have got to pass and find jobs afterwards, right? So what do we do to try and, we can't magically prevent people from failing, okay? I can't, is it? What I can do though, thought there was somebody who was wanting to, what we try to do is to address this problem. What we can do is, instead of waiting towards the end for these people to fail the first year course, this is a first year course, by the way, right? What we're going to do is we're going to build a solution. We'll mine data and use the data that would have mined to build a solution, okay? A solution that is going to enable us to identify before these people fail, right? You come maybe at Unze in first year, you're enrolling into this course. Before you fail at the end of the year, this is a full course, by the way, right? You write the exam towards the end. I don't know if it's November, December, or something. I guess now it's like September, something like that. Before you fail in September, we want to know that you are most likely going to fail, right? So what we do, well, we're going to build inference models that are going to tell us this person is most likely to fail. This person is going to be most likely to fail. For us to do that, we have got to mine data. Okay, so you understand the problem here. We understand the problem. The solution is simple. We are not going to come up with an Alexa, a magical solution that will prevent people from failing, but we are going to build a solution that will tell us this person is more likely to fail. And if we know who is more likely to fail, then we can come up with an intervention. As course instructor, one of the interventions will be something simple, right? It's like, those people I've identified to most likely fail. I will organize dedicated tutorial sessions. I'll identify good tutors and put them in one group. They may not know. Huh? I'll put them in one group and I'll tell the tutor to focus on specific things for that particular group. What else can I do? If I know that you're most likely to fail, I'll probably call you, right? I'll send you an email, come and see me, right? And then maybe I'll probe. What are the challenges you are having in this course? Well, I can't understand. Computer architecture, the instruction set architecture is hard. Or mixed assembly is too hard for me. I don't know what's going on or something. So you better understand here the issue of the solution, right? The solution may not necessarily fix the problem directly, but forget about that. We're going to revisit this later on. What we did was we built, and I'm going to show you something here. I want to start off with with a data set. This again is going to be a data set we're using in this course. It's a data set for a student at risk of failing, right? I'll call this computer systems and architecture, UNZA, and then I'll say pd.read or something. What we did was we mined data, right? Remember, we're talking about data mining here. And I'm going straight to the end goal. And maybe, for the end goal here, what I'm going to do here is I'm going to paper, data lab, and predicting paper, data lab. I'll get through with the current version of something that we submitted here. So we're going to build this. We just built a binary classifier in this particular case, but I would want us to actually read this together in this course, because it turns out that in addition to this space thing here, in here, we actually discuss a couple of other interesting things here that we're supposed to discuss in the course, right? So there's a bit of clustering here, right? That showcases, this cluster, by the way, is showcasing. It's a K-means cluster that showcases, and I have 5 clusters here, right? They are properly highlighted here, right? What you want to do is look at this cluster here. This is a cluster of final exam scores against engagement, which is Moodle hits in the x-axis. What is this telling us, right? If you look at this cluster, these are students that did not engage with the course. Now, here's the thing, right? Passing at UNZA is somewhere where? Somewhere right above the 40 here, 45 somewhere here at undergrad, right? Somewhere here, right? You notice that most students that fail engage less, right? In other words, they were not interacting on the Moodle and stuff like that. And we'll talk about engagement, about features and how we extract data or how we mine for that data later on here. But I'm just trying to show you the final form, right? The things we did. Not only did we classify, the final thing we wanted here is we're building a binary classifier, right? That tells us, right? That tells us whether a student is going to pass or not. And there's a whole bunch of things we did here. I wanted to go to the results here, right? And you probably want to pay attention to here because we ended up using logistic regression anyways. But there though. Now, here's the thing. The data set we are using, and we're going to use this together. It's slightly more complex. So remember when I said the DSpace data set has how many columns? Right? How many columns does this thing have here? It's like 8, right? Okay, 8 of them here. It's not too many of them here. 8 of them. Identifier and stuff, and then I also showcased the what do you call this? The sample records that you have, right? Well, the student at risk of failing, right? This has significantly more attributes. 69 of them. Okay, 69 of them. And well, it's like, but what are they like, right? Well, yes, we're going to do this. These are the ones, right? Quite a number of them, actually. like I said, for var attribute or something in here. Let's just print out var attribute so that you see that there are quite a number of them or something. These are the ones, right? All of these, is it? Student ID, student name, these are anonymized, but they won't know who they are. But and I take pride in this, right? I mine data myself. I mean, some of the data is easy to mine, some of it is not so easy to mine. Some of it is stuff that is error prone because it was created by course instructor myself. Some of it is automatically generated by systems, right? So 69 attributes. And incidentally, for most of these things here, I guess I can also just open up the data here. And just open it up for you here. This is not comma separated, it's pipe separated. Right? So this is the data set as it is in its raw form, it's a CSV file, right? It doesn't have a lot of observations, right? Like a little over 450. And once we clean up the data and stuff, we actually remain with less, right? When we handle null values. But these are the columns here. Student ID, student name, right? The whole 9 yards here. Now here's the thing. This is a final data set. But, right, it turns out that this information is coming from a lot of different sources. Now the paper itself, I'm not sure this, I think, still being reviewed or something like that, a series of iterations, but can you please mute your microphone wherever you are? But this data is coming from a range of sources, right? Where is it coming from? SIS. So I go in SIS. When you go in SIS, your view doesn't give you access to this information, right? But you have nuanced information in SIS. Which school you went at, right? Your results, I guess, like grade 12 or something. Where you're originally from, right? Your gender, you know? So we have, from SIS, we're getting things like demographic data, right? Age, gender, your sponsorship status, whether you're accommodated. I want to talk about these things. These things I'm highlighting are called features, right? Okay, they're attributes, but they're called features when you're looking at data mining, machine learning, or AI. And it turns out that the idea behind features is simple, right? If you're building an inference model, right? In this example I'm giving you, model does what? Model does something simple, right? Will student fail, right? It will tell you yes or no. This is what the model does. But the way you're building this inference model is you feed it data, right? This data is in the form of attributes. Now, if you look at the data I'm showcasing to you, the data we mined, right? There are so many attributes. The question you're answering when you're building these models is you experimentally determine things like, do you think the gender is going to be an indicator or a key ingredient in determining whether somebody is going to pass or not? I don't know, right? And you want to be very careful, by the way, when you're doing sensitive things like this, is it? You want to be very careful when you're building machine learning models. What we're doing here is we're identifying colorations, right? If we were to build a model, which we did with variations of models where we're just looking at gender, for instance, if we find that gender is a strong predictor of whether somebody is going to pass or not, we're not saying that because you are female, you're going to pass, right? There are other underlying factors. It may not necessarily be your gender. You understand this, right? But we're saying there's a coloration, there's a relationship, there's a positive coloration. Well, there's a coloration in this particular case, okay? If you remember I don't know if you've been introduced to some research in CSC 4004 with Mr. Sumkanga, just briefings, but there's this, what they call causation versus coloration, is it? Right? Like at grade 12, they'll say, in Zambia, females pass more than males. Well, we can't sit here and say females are more intelligent than males, right? Because you are female, then you're going to, if you're born female in Zambia, you're going to be more intelligent. We know, right? The underlying causal factor, right? The girl child initiatives. There's more support to the girl child. And there are people, right, that do other fields of study that will help explain those things. There have been studies that have been done here, right? So there's less focus on the boy child or something like that. I'm sure you've heard of these things here. Now, so what we're doing here is we're saying this data was being mined from SIS, and from SIS, it's not just your demographic factors, right? What else is there? Well, details of your course workload, right? So at first year, some students who have overloads and stuff. In this particular course, students have a major and a minor, right? So we discovered that there's a correlation between your minor, certain minors, we are failing more than other minors. Okay, what else? So data from SIS, right? Data sources. We are harvesting data from SIS. By the way, to give you an example of this, examples of data we are harvesting from SIS, literally, I'll give you an example of what we get from you guys, right? This is from SIS, these details here. But these are just demographic factors, not too detailed here for the course, right? So I know these are not useful here, like your computer number and your name, not useful, but I know your gender, right? Your major and stuff and stuff like this. So it's information like this we're extracting. But other views of SIS will allow you to extract, more nuanced and interesting information as well. So there's that, right? What else? Well, what I normally do in my first year courses especially, or in that particular first year course, is I would administer a questionnaire, right? I was genuinely interested in finding out information about students I was going to teach. So what I would do is I don't know if this is going to work here, but I had a self-administered survey, and I want to show this preliminary, later on preliminary, because we're going to rebuild this data set together, right? So it's a preliminary survey like this, where it's a simple survey really, but it allowed us to extract interesting information, right? So Google Forms, right? I get your name, where you reside, right? Where are you from? Did you study computer studies at school or something? Okay, what else? Have you done any computer training thing and stuff? Now, I'm saying all of this because as a person who had taught this course for a long period of time, I had developed some knowledge, right? Knowledge regarding what are the important attributes, key markers that will help you figure out whether somebody is going to pass or not, if this is making sense, right? Yeah. So anyways, we have the survey and we're able to pull out that information. What else? Well, there's information that was coming through from Moodle logs. Now, in case you're wondering, well, why Moodle logs? Well, we realized systematically, right? We realized that one of the key indicators of whether somebody is going to pass or not is engagement. I'm going to tell you something. The reason why in all my courses I give away 5 marks, right? Literally, I fought for some courses. I fought to justify why are you giving free marks, right? For participation. The reason why I give free marks for participation, like I've told you that you're going to get marks for attending, right? Is because implicitly you are engaging. If I'm forcing you to attend this class, right? You are engaging with the course. Okay? So engagement is a very strong indicator of whether somebody is going to perform good in any course, actually. Certainly in computer science, right? Now, we didn't really measure engagement by taking attendance, but because it was difficult. It's a large class, by the way, to get attendance, especially physical attendance, right? People sign, there's fraud, people are signing for one another, but we clamped out and we zero them out, right? We identify them, and they're given 0 marks for signing on behalf of other people. But so engagement, the question we want to ask was, how do you measure engagement? Well, in our case, we realized we can measure engagement by using the LMS, the learning management system. So we go to Moodle, right? And this is why we are seeing this, by the way. We go to Moodle and we get the usage logs, right? So we kind of like, we go to the course site, and I want to use your course right now as an example. And then we try and see, right? If we look at the logs, what is the level of engagement for each and every student, right? So what I'm going to showcase right now is, this is for 792. I'm going to go through to you. You don't have this view because of your role, right, as a student, but I have access to the logs, right? And right now, if I wanted to actually, I can pull out these logs and try and see, right? Who are some of the people that are engaging with the course, right? And I can quantify engagement in many different ways. Maybe I can look at a specific resource, right? Notes that I'm uploading and when they're being accessed. Maybe the period between when they're uploaded and accessed. I certainly would say, well, John Chola is engaging, right? Because he's made an effort. He has downloaded the notes or whatever, right? Lewis and stuff like that. Now, I want to pause here, right, and showcase to you that in as much as the final form of the data set, remember I said it has 69 attributes. There's a separate data set for SIS, different views of SIS. There's also a separate data set for Moodle logs, right? I think I have access to the, I have the Moodle logs or something, paper predicting learning outcomes data set, something like that. Oh, I'm going to open up an example of Moodle. This may be detailed here. I'm going to open up from 2020 or something, right? So maybe it's not very useful here. I'll open it up instead of, I'll use my spreadsheet application or something like that. So we mine the key thing here, because we're looking at data mining, we mine data also from Moodle. How are we mining data? There we go. This is the data we are mining. We mine it, and then we have it like this. Some of these are derived fields, like because the original Moodle log here, ODP, ODS, the original raw logs here are not as simplified as the final fields that we have, the attributes we have, the features, right? So a number of these are derived fields, but the final form is raw logs. This is it. These are the logs here. You notice how nuanced it is. We even know which IP address, whether you're using the mobile application or the web-based application, right? If you download the app and stuff, and guess what? Which specific, what are you doing on the Moodle? How much time are you spending on the Moodle or something? Now, I want to pause here, right, and remind you that I'm walking you through a process of what sort of data we are mining to solve a simple problem, is it? The problem we're solving is, want to build an inference model that will tell us, is the student going to pass or not? But what I'm trying to say here is that for you to come up with a solution that does this, you go through a systematic process, right? So we mine Moodle logs anyways. That's neither here nor there. And then these are some of the, we started late here. You guys don't have almost, yeah, I know you don't have, we're almost done. You don't have any other class, so we can extend. We started late also because of some other things. I'm going to accelerate going forward here because I was spending more time on things that are going to be used as case examples. So I'll share a paper, I guess, a write-up based on this. And then I will also already share the data set, right? So I can already start familiarizing yourself with it, because the next thing we're doing is we're going to have a crash course introduction to the libraries we're going to be using, and also Python, right? Anyways, so that's Moodle logs, right? We're mining LMS logs. Now, I'm going to tell you something here, right? Not to put myself up on a pedestal, but I would like to think that there are very few people, very few members of staff at the UNZA that would want to waste time and analyze logs. But perhaps I guess central administration would be interested in doing this analysis. The long and short of it is, we can mine data in other interesting ways, right? Like to try and check for compliance. Which lecturers are using Moodle, and to what extent are they using Moodle? We can mine all sites, right? All Moodle sites at the UNZA, and tell central admin to say, in terms of compliance, we've discovered that, I don't know what this is here, but we've discovered that, I'm going to go School of Natural Sciences. What is this one? Okay, these are things that I have access to, I guess. And I don't know. Okay, this is weird here. Postgraduate, undergraduate one, and stuff like that. We've discovered that, in the let's say in the department of computer science, only X number of lecturers are fully engaged in it. All right, they're actually extensively making use of Moodle or something. So you can use data mining for that, right? There's a whole range of kind of like problems that you can solve when you're mining data, ideally. There's more things we've done. We've mined Wikipedia data, right? I'm probably going to share another reading list with you because we do quite a bit of Wikipedia research. There's a conference paper we presented where we're able to quantify just how bad Wikipedia contribution is, right? In Zambia, It's horrible, everybody, right? Where you find that pages on and about Zambia are created and updated by people that are not from Zambia, right? How are we able to quantify? Observe. We were able to quantify this. Come on. This, right? By mining data from Wikipedia, right? And it's not, for some platforms, it's not difficult because they're APIs, yeah? We're able to mine this data, if that makes sense. So there's a whole range of kind of like problems we are solving, automatic generation of Wikipedia content. It's only this year that I don't have students that are working on Wikipedia. There's a master's student who started working on this problem last year though, but I haven't really thrown any kind of Wikipedia-centric problems to undergraduate students. And then other types of data that we're mining here this is interesting here. We're mining data from so-called Dashcam files. So when certain people are sick, right? When they are affected by certain pathologies, they'll be required to be examined or scanned, right? So go and get a chest X-ray or something if you have suspected pneumonia or tuberculosis or something like that, right? You have a fracture, you hit yourself, they'll get an X-ray or something like that. You have cancer and stuff, they'll do a CT scan, right? Or an MRI or something like that. Well, one of the things we've been doing is we're mining Dashcam files. And again, I'm going to share some publications as reading lists at a later stage when we cover certain specific topics to demonstrate how we're doing this. We're not supposed to look at images in this course. If it was a full course, I was probably going to sneak it in, but because it's a half course, we don't want to sacrifice the important content here. But what I may do is force you to read or have you read some of the works we've done. But to give you an idea, I've worked with students. More recently, there's a smart student who did a BSc in software engineering at the UNZA, and Malaysian Zumara. He's graduating in next coming days with a Master of Science in Computer Science. And one of the things we did was what he was doing as part of his thesis, right? It's a thesis because he was doing a master's by research here. What he did as part of his thesis is he built two models, right? So how to build these models? You mine images, right? X-rays, right? And I don't know, go here. I may share a direct link to a live application he built. But he built two models, a classifier that takes in as input an X-ray like this, and then it tells you, it's a binary classifier, tells you this is associated with pneumonia or not, so that the doctor knows, say, this is more likely suspected pneumonia. What else? He was solving what's called a classification of localization problem. So he also built a detection model, a localization model, where the model generates a bounding box, right, of an area that has or that is suspected to be problematic, if this is making sense. So I'm doing all of this because I'm showcasing you the different types of data we are mining. The interesting thing here, right, is that irrespective of the problem, the techniques that you use are the same. So I'm going to tell you this. The techniques that were being used by Malaysia to build these models are similar to the techniques we use for pothole detection. Why? Because they're images. The only difference is in this particular problem, we are looking at detecting potholes. In this particular thing here, we are looking at detecting pneumonia, right? Input, image, if this makes sense. Techniques, the same, right? Which is why when you're working on vision-centric problems, you will find people using frameworks like, oh, we're using YOLO or something, or RCNN, right? Irrespective of whether you're working in a different sort of domain or something like that. In fact, if you wanted to build like some CCTV-centric application that tells these department stores, say, we're building a solution that will tell you this is suspected person who is shoplifting or something. Same technique, right? You're detecting shoplifting, right? People that are snatching things and putting them in their bag or something like that. Maybe the other difference between this and here is because the input here is motion picture, right? Video, okay? But anyways, what else is there? There's a whole range of other problems, as they relate to Zambia. I cycle a lot. When I'm cycling in the outskirts, I'll find this. So in fact, even right within the heart of the CBD, you'll find CCTV cameras, right? Some people have been caught here. I don't know if you guys know about this, but I was caught one time. Genuinely, I did not know. I did not know I was speeding. I was along Kafue Road or something, and I get an SMS. There's a link. I go there. I check for my license plate, and they have like an image, of my vehicle, my license plate, with me right there. I didn't check also my license plate, but with me right there, right? And I couldn't say no. I paid the fine anyways. I paid the fine anyways. So you have this, right? It's a classic problem here where maybe you can help mine information that is being captured. Because I'll tell you one thing, right? Most of the things that are done in the Republic as they relate to this infrastructure, CCTV cameras. By the way, these are also in high density areas. If you go to Ngombe, I've been to somewhere in Lilai there. Is it Lilai? Where there's that police training camp here. It's a high density area and I found infrastructure, right? Like, do they really analyze this stuff? I have someone I know close to me who has told me that they do actually. Apparently, there's even a unit that is dedicated for doing this. But the key thing here is you can help them mine this information and do a lot of interesting analysis, right? If this is compliance and all those things, so that you go to RATSA and you tell them, RATSA, you can't be saying that you buy vehicles that be mounted with cameras. I don't know if you heard about this. With cameras, right? It's like far-fetched. It's like not really far-fetched, really, but it's a suboptimal solution. But as an expert who understands this space, we can go to them and say, we can come up with a much better solution. I don't know if you heard about this, right? A while back, like literally at some point last year. Usually, most of these parastatals or government entities, they'll jump on the bandwagon. AI here, AI this, no, buy vehicles, right? Really? Okay, that's fine. But you can, and then a while back as well, right? Back in 2019, government was like, well, we need help to monitor content on radio. Radio, okay, 24/7, right? There is a thing you can do here is, say you're going to rely on, and this is what IDA does, right? Yeah, you're going to rely on members of the public to say, well, this radio station broadcasted something that can be classified as hateful speech on this particular day, right? Radio Phoenix or something at this time. But that's not really very useful, is it? You can mine data, right? If you want, you can, in real time, you can capture, right? Content that is being broadcasted on radio or something. Obviously, that's audio, you convert it to speech, and then you analyze the speech or something. I don't know how far this went, but because, again, government is really good at policy formulation, right? Or telling people what policy direction they're headed towards, but implementation is almost non-existent. Yeah, if that makes. But what we're saying here in terms of the course we're doing is we can mine data, right? And it's not difficult to mine, right? I use VLC myself to listen to the radio, like Parliament TV, for instance. You can do a lot of fancy things. Now, this is all good and interesting and stuff, but I want to tell you something here that for us to accomplish all of these things, I'm talking about some of them I skimmed through. There are a lot of interesting projects that students have been working on, right? Like this year, I'm working with students that are working on interesting topics as they relate to data mining, for instance. But all of this is interesting. The key thing, the key takeaway I want to leave you with here is that the key ingredient in all of this is data, right? Without data, there's nothing like data mining, right? This is the first starting point. And not just data, but quality data. And in fact, it turns out that it's one of the reasons we're going to obsess a lot in this course on the process we go through to clean data, for instance, right? Now, I'm going to skim through some of these things. We can include them as reading lists as part of our discussion with ethics here. But I wanted to talk about statistics that are captured by Stanford, Oxford Insights, not Stanford, Oxford Insights, right? Where they determine the AI readiness, right, of countries across the world, ideally. You notice that at the time I was getting this, in 2022, I should update this, the readiness index for Zambia was quite low, right? Compare and contrast with countries that are rated higher, like the United States. These are out of 100%. But the key thing here is that the way they compute this is they look at different aspects, right? Pillars, they call them. Policy direction, so government, the technological infrastructure, right? You have it. At the time, Zambia was, didn't really have technological infrastructure, right? I think it's still a problem here. But what about data as well, right? Notice we performed relatively well for data in this particular year. But anyways, then you can break apart these pillars into what they call dimensions, ideally, right? That's neither here nor there. Now, it turns out that one of the things we're discussing in this course is, like I said, we want to understand the pipeline that we go through to solve this, to mine data, right, and derive insights. And it turns out that the pipeline is associated with stages that we're going to study together. But I want to tell you something here, right? And that's that if you look at all these different stages where you're building these models, inference models, you're understanding the problem, you're building the solution, you're deploying it. These are not as difficult as the part that involves collecting data, cleaning it up, transforming it, right? And people have done studies. So you notice what this bar plot is showcasing here are the generic stages associated with data mining and the relative effort on the y-axis, yeah, associated with each stage. Domain understanding, data preparation, data modeling, we are building the model itself, evaluation, assessing the model, relative success of the model, and then deployment. Deployment should be the simplest for you guys because you know how to program, right? Deployment means building a solution. So if I'm using a chatbot like DeepSeek, for instance, right? Boom. Behind DeepSeek is a model. Okay. There's actually a model, and it turns out that, and I think I mentioned this in my inaugural lecture to say, when it comes to models, yeah, when it comes to models, it turns out that, zoom in here. When it comes to models, if you look at DeepSeek, behind the scenes, there's a model, right? And I don't have DeepSeek here, but there's a model, right? Like this particular case, I guess it's DeepSeek. I don't know if it's in version 4 or something, the most recent one, right? But because the model itself is not that useful in its raw form, what you do is the way you deploy that model is you build an interface. So Gemini will build an interface similar to this, right? It's a simple interface, but behind the scenes, when you're writing your prompt here, right? When you're writing a prompt, I've never really tried to write a prompt with gibberish, right? I don't know what it's going to say. When you write a prompt, you can interact with this interface in so many different ways, right? This is part of deployment. When you're sending a prompt here, behind the scenes, you're sending a query to a model, right? What you do when you're building inference models is you mine the data to build the inference models, and then you deploy the inference models. You deploy them in such a way that the layperson will find it a lot easier to use. Like if I'm deploying a model that tells me whether somebody is going to pass or not, I'm just going to put something that tells me yes or no, right? The nice user interface that allows me to upload information about students, maybe through a CSV file or something. Okay. Anyway, so key phases of data mining. Now, what we are doing in this course, right? For us to be able to do all of these things I've talked about, is we want to work towards these learning outcomes. These are available on the Moodle. There's a course outline that I've made available. But at the end of this course, by August, unless if they extend this term again, we should be able to explain, data mining and data warehousing concepts, applications, and challenges. Now, what I want to draw attention to here is the fact that these learning outcomes are going to manifest themselves in various topics. In some instances, we'll cover different topics for us to accomplish a key learning outcome. In some instances, just one topic or one lecture series will be sufficient. I don't want to read them verbatim here, but these are the learning outcomes, right? And this is how they appear in the, what do you want to call this? The course outline, which is available on the Moodle, right, for this particular course. Now, for us to accomplish this, what we're going to do is we're going to cover these topics. Okay? So we're going to start off next week, Monday, when we have class, by learning the tool set that we need for us to be able to do the practical part of data mining. So we'll do a repeat for those of you that have done Python. We'll quickly go through Python. This is not an introduction to programming course, but I'm just going to focus on the crucial parts of Python, right? So that you don't get lost when I'm sharing example code, okay? Because this is a practical course, the exam, the test will have, and the quizzes will have programming questions. Okay, so we're going to start off with an introduction to Python and related tools, like the notebooks and libraries that are used. And then we're going to move on to topic or module number 2, where we're looking at the pipeline itself. We tend to use the established ways of this pipeline, right? The diagram here to the right is showcasing the so-called CRISP-DM model, but we will discuss SEMA and KDD, okay? Although we're going to emphasize on CRISP-DM methodology. And then we're going to look at a module that teaches us how we clean data or how we process data. And then we're going to look at the topic that's called exploratory data analysis, right? Part of the reason we're doing this is when we get to discuss dimensionality reduction and other related topics that we're supposed to cover. Then afterwards, we'll look at how we transform the data, right? Converting specific types of data into numeric form. And then we'll look at how we build classifiers and how we build clustering models, ideally, how we cluster and how we build binary classifiers, multi-class classifiers, I think, as well, is what we're supposed to do. Anyways, and then we then jump on to look at the warehousing part, ideally. I left this here because I don't know if Professor Phiri and Dr. Nyirenda are still going to come in this year, probably not, but we had initially, a while back, agreed that they would come in as well. And then we're supposed to look at ethical issues. What I normally do is the ethics discussion is discussed early on in the process. And instead of focusing on the things that are outlined in the defined kind of course document, what I do is I force us to look at the Data Protection Act, right? This is the only piece of legislation that we have in the Republic that is closely related to ethics as it relates to what we are doing in this course, right? So at your own time, you probably want to familiarize yourself with the Data Protection Act of 2021, right? I know the Ministry of Technology and Science has been hinting at the fact that they would want to revise this now that Parliament is no longer in session. I don't know how far this is going to go here. It's not a very long document, right? And it's pretty easy to understand if you're technically inclined like yourselves. Okay, so these are the things we're going to cover here. As part of homework today, I'm going to share this slide deck, updated slide deck. There's a reading list. There's a paper that I mentioned earlier, automatic classification of digital objects for improved metadata quality. I'm having you read this because the data set is associated with what is discussed in here. For you to be able to understand what we're going to be discussing, you want to read this. The other reading list is this paper. Not that we're going to look at this this data set, but it's related to, it's actually this paper by Malai, the one I was talking about, right? This thing here. Yes. Okay? Just for you to understand. Now, I know some of you, I'm sure, were maybe typing, but Lighton, it's after 13 hours, I know you have nothing better to do. There's no class at 13 hours, I know this. Okay, and I didn't want this to move to next week, right? I wanted us to finish off this introduction. So this is me hoping that this context I've provided gives you an idea of where we are going, but also it motivates you to pay particular attention to the course because, like it or not, there's a hype here. There's this AI hype, and usually in life, you want to jump on certain bandwagons, right? There's certain skill sets that are increasingly being sought after. When you're attending these interviews, they'll probably ask you if you know how to do things as they relate to some of the topics we are covering here. These things have real-world application in industry. Literally this year, I was, along with Professor Kaleji from CBU, we were doing a masterclass, an ICTA's masterclass in Livingston, right, where we were talking about some of the things we're going to be covering in here. A lot of organizations are headed towards this direction. Okay. I don't know if you guys have any specific questions. I don't know if it's the part where I check to see if there are questions in the chat. Maybe not. Can I start from the top here? I don't have host privileges. Oh, Humphrey, sorry. I don't know what I did with the configuration. I'm going to change this configuration so that you and and Deborah have host privileges. You're going to help us manage things, mute people that would be unmuted, and also, admit people, right, and stuff like that. Good afternoon, sir. The lecture time has elapsed. I know, but Emmanuel, where are you rushing to, right? There's nothing to do here. You're not doing anything. Since these LLMs are kind of built to hallucinate and provide a kind of hallucination, how do they fill the knowledge gap? Well, the simple answer to that question, this is a wonderful question. We're not covering LLMs. Phil, Samakai, you leverage what's called retrieval augmented generation, is it? So he's asking, say, LLMs hallucinate, right? If you ask it, tell me about Professor Jackson Phiri, I dare you, you'll find that it will say, well, Professor Jackson Phiri is, I know this, maybe things are, tell me about Jackson Phiri or something. We'll probably tell you wrong things or something. Well, you can leverage what's called retrieval augmented generation, right? That's a way of doing that. This is somewhat recent here, I guess. Okay, it's giving you options as a football and stuff, but you can leverage retrieval augmented generation, but also you can retrain, right? A model, is it? Yeah, if that makes sense. You can fine tune it, okay? You mentioned about a homework. Explain that again. I'm going to share this slide deck. Simple homework. You read so that you understand the data set. You're going to read this paper and this paper. I may throw in another paper. If you want, I will explicitly create homework on Moodle, right? It's not going to be graded, but it's for your own good. Usually, when we have something indicated as homework or an assignment, when time comes for tests or the exam, you should expect something that has been carved out as a homework or assignment, right? Miss Deborah has the hand up. Yes.
Sir, I have a suggestion on top of on top of what I think that was Emmanuel who said about the lecture lapsing. Said, is it possible that we can maintain time moving forward, seeing as how we only have 2 weeks to the mid-semester exam, that we don't have study break and we have to balance with?
Ms. Deborah, we don't have. Has it been confirmed that we have 2 weeks? Senate is going to sit, right? I don't know if there's a new update that I'm not aware of, but I've taken note. Today was different here. But also, Ms. Deborah, it says 30 minutes. But also, I'm looking at you guys. I'm looking at my thing right now. You have nothing to do here. What are you doing? You guys, okay. Yeah, I've taken note, Ms. Deborah. But this was like, there was a delay and stuff. I've taken note. We're going to stick to 45 minutes each, actually, to be honest. So it'll be exactly, kind of like 90 minutes, 1.5 hours, ideally, right? 5 minutes per session. I've taken note, Ms. Deborah. Robert Nchinga has a question. Because people are complaining about time, Robert's question is going to be the last one. And then if you have questions, there's a mailing list. Shoot an email, the mailing list. Get used to the mailing list, right? The mailing list is for you, not just me. Yes, Robert.
I don't know if I'm audible now.
Yeah, Scream, you're a bit low.
So I was saying it's an addition to what I said. So actually, the second that is an updated as
Yeah, your audio is horrible. Sorry, I don't know if I'm the only one. Either type type the question or something, or you can send it via email, and then I'll address it. In fact, yeah, yes, Joshua.
Sorry, Doc. It's out of this class, but I wanted to find out for me today.
Well, if it's out of this class, shoot an email, and then we'll discuss that. I'll have to check the timetable though. I haven't checked your afternoon timetable. All right. You are supposed to request for data. You haven't, you guys. You're not serious. What is wrong with you? You're Morgan. Okay, guys. Thanks a lot. People don't want us to have class, so we're going to shut this down. That's the job. We are going to shut this down, and please, and I'm pleading with you, right? Although, if you don't complete assignment number 1 where you're choosing a group, you will lose marks. There are marks allocated to that. If you do not form a group, a valid group of 5 people, by tomorrow, 23:59, you will have marks deducted from you. from your overall course score. I'll take this seriously if I were you, but as always, when you have a large group of people like this, there are always people that won't be serious like that. Okay, thanks a lot. If there's anything pressing, please reach out to you can have the course reps reach out to me, and we'll fix. I hope this thing was recording. I don't know. This is horrible stuff, right? I think we were not, I don't know if we were recording here. You can reach out to Miss Deborah and Mr. Humphrey. But also I want you to get into the habit of sending mail, right? Just send an email too. If you have something you want to contribute, right? You send a message to the mailing list, CSC 4792@unza.zn. Say, I found this nice resource. You may be interested in doing this. This mailing list is not for me, right? It's for you or something. Janet says, yes, you can put that. I mean, I will put it on the Moodle. Okay. Keep an open mind. I know there's difficulties of organizing data and finding stable connectivity. 4 times in a week, you have 4 courses, I think, plus meetings with your supervisors. You know, I understand, I sympathize. If there's anything I can do, please let me know. If it's something within my reach, I will incorporate that into the course. Okay, good day, bye.